Welcome to this instructional video about the water solubility of organic compounds. So, let's say you're given some organic compounds and you are asked to rank them according to water solubility. Which one is the most soluble in water? Which is the least soluble in water? Luckily, we've got some what I would call guiding questions to help us make this very important ranking. So the first question you should ask about each of the molecules is, what is the hydrogen bonding capacity of the molecule? Now, what is hydrogen bonding capacity? Well, we already know this, I believe. It is the number of H-bond donors plus H-bond acceptors. And sometimes I just use a little d for donors and a little a for acceptors. In fact, I often call this, what is d plus a? So we have a general rule here. In general, if the larger the d plus a typically translates into increased water solubility. If you want to be soluble in water and you're an organic compound, you need to form hydrogen bonds with the water. That's pretty clear. So the more capacity you have to form hydrogen bonds, typically the greater your water solubility. But that's not the only thing we have to consider. There's a second question here. How large is the molecule? And really it's not about how large it is, it's about hydrophobic area. That is, how much of the molecule is hydrophobic or water hating? And typically you can just look and see how much of the molecule is hydrocarbon, because that's really the source of hydrophobicity or nonpolar nature of an organic compound. So we have a general rule. In general, as you increase what I'm calling the hydrophobic area, the amount of hydrocarbon in the molecule will translate into a decreased water solubility. And again, I think that makes sense. The more water-hating the molecule is, the less soluble in water it will be. And so you have these two guiding rules, and typically consideration of both of these will lead you to an answer in terms of which molecule is more soluble in water. So let's do an example here. So let's do some competitions. And this will help us review our organic nomenclature as well. So this is a win-win situation. So which is more soluble in water, diethyl ether or 1-butanol? Well, diethyl ether is going to look like this. And I'm going to be a very good accountant of electrons because that's what I do. I take pride in my work. I'm going to take it slow, do it right. There's diethyl ether, and here is 1-butanol. Again, trying to make very special care here to put in lone pairs. And so let's start with question number 2 on this one. What is the hydrophobic area of these two molecules? I'm going to call it a tie. It's pretty close. There's 2 ethyl groups in one of the molecules, and then there's this R group with 4 carbons in it. I don't think there's a big difference in the hydrophobic nature of the molecules. So that's going to take us to the first question, what's D plus A? And I think D plus A is going to shed some light on this issue. So D plus A equals the number of donors plus acceptors. There's no hydrogen bond donors in diethyl ether. There are 2 hydrogen bond acceptors, so D plus A equals 2. Let's go over to the other one. The number of donors in 1-butanol is 1, plus the number of hydrogen bond acceptors is 2, that's 3. It looks like 1-butanol has a greater capacity to form hydrogen bonds with water, and in terms of both of these molecules, they have a very similar hydrophobic area. I'm going to give the victory to 1-butanol being more soluble in water. Definitely. All right. Well, look at the second competition here. 1-butanol or 1-pentanol. So let's look at this. So we've got a 4-carbon alcohol and a 5-carbon alcohol, and really the only difference is one has an additional, if you want to say, like a CH2 group in it. So let's do this one a little bit differently. So 1-butanol is like 4 carbons OH, and 1-pentanol is going to be 5 carbons OH. So what I'm going to say right away is that both of these have the same D plus A. Okay, and again, let me be very careful. Let's put in the lone pairs. So for both of these, D plus A equals 1 plus 2, which equals 3. I don't think hydrogen bonding differentiates these two with respect to water solubility. They have the same ability, the same capacity to form hydrogen bonds with water. So probably we're going to be talking about a hydrophobic issue, and I don't think it's a big stretch for us to say, oh, wait a minute, this has 5 carbons, the other one has 4 carbons. This probably has a higher hydrophobic area, so it will be less soluble in water. So our winner here, which is more soluble in water, is definitely going to be 1-butanol. All right, that's some examples of how you can do some predicting on water solubility. Thank you.